we started off talking about what do we mean by random experiments, outcomes, sample space, and evidence. Then we looked at examples of each of these, where we looked at 3 different examples. Now we want to discuss union, intersection, and complement of evidence. Now the idea is this: since sample space. Now the idea is that since sample space and events are sets, right? We already talked about the sample space is the set of all possible outcomes, and events are subsets of the sample space, so they're also sets. Now, since sample space and events are sets, we can apply rules from set theory here, right? Because they're sets, right? We can apply rules from set theory here. We can apply rules from set theory here. Where we're talking about set union, set intersection, and so on. Right, so basically the idea over here is that we know the sample space is the set of all possible outcomes. Events are subsets of the sample space, so they sets themselves. Since both sample space and events are sets, so here we're going to apply rules from set theory. But first look at intersection of two events. Now, an intersection of two events is the set of all common outcomes. So the key word here is common outcomes. So it's the set of all common outcomes between the two events. So whenever we're looking at the intersection of two events, we're going to get a set of all common outcomes between the two events. So when you find the intersection, it's also a set, right? Events themselves are sets, and when you find the intersection, you get another set. When you find intersection, that is also a set. So whenever you're looking at the intersection of two events, it's going to be a set of all the common outcomes between the two events. The intersection of two events, E and F, is represented by the intersection of two events, say E and F, is now how can we write the intersection of two events, E and F? We can write it as represented by. So there are two ways you can represent this intersection between two events, E and F. We can write it as E intersection F. So using an inverted U. We can use an inverted U. We can also represent the intersection of two events, E and F, as EF. So we can write the intersection. So E intersection F can also be written as, so E intersection F can also be written as just EF without the inverted U sign. It can also be written as EF without the intersection sign. So intersection of two events is the set of all common outcomes between them. So we can write the intersection between any two events of any two events, E and F. So that's just the intersection of any two events. E and F is represented using an inverted sign, or we can also write it without the intersection sign. So let's look at an example. So we're going to use example 3 here. Now example 3 we did earlier in an earlier video from example 3. So now if you recall from an earlier video, example 3 was that you were looking at a random experiment where 2 dice are rolled. So the random experiment here was 2 dice are rolled. And here we defined 2 events. So here we defined events. We defined E1 to be the event. Sum of the 2 dice is 10. And like we said, E1 includes the outcomes of the first is 4 and the second is 6. Or it includes the first die is 6 and the second is 4, or both are 5, right? So these were the outcomes in event. So E not E1, sorry, this was just E, my bad. F is same number appears on both dice, right? Same number appears on both dice. So this was just the event without 6 outcomes. So the both dice have 1, both dice have 2, both dice have 3, both dice have 4, both dice have 5, and both dice have 6. Right, so from example 3, now if you just recall this example looked in detail in earlier. So from example 3, we know E intersection which can be written as without the intersection sign or with the inverted U intersection sign is just like we said, intersection is the set of all common outcomes between them. So let's see what common outcomes are between them. So we can see the intersection of these two events that we have will be the set of all common outcomes between them. The only common outcome, you can see you have 4, 6 here, but you don't have a 4, 6 here. You have 6, 4 here, but you don't have a 6, 4 here. The only common outcome between them is 5, 5. So E intersection F, we know is the set of all common outcomes between them. There's only one common outcome, 5, 5. So it's the set containing that outcome. Because there's only one common outcome here, 5, 5. So E intersection F is going to be the set containing that common outcome 5. So this is intersection two events. Now let's look at union of two events. So now let's discuss union of two events. Now when you talk about union of two events, it's set of all outcomes. So this is set of all outcomes in first event. So the key word here is all outcomes in first event and all outcomes in second event. So when we're looking at the intersection of two events, we're only looking at common outcomes between the two events. When we're looking at union of two events, so it contains all the outcomes in the first event and all outcomes in second event. And here just keep in mind, we write the common outcomes only once. Any common outcomes between the two events are only written once. We write the common outcomes only once. So in intersection, you have the set of all common outcomes. In union, you have the set of all outcomes, right? So essentially a union is set of all outcomes. Union of two events is the set of all outcomes that belong to at least one of the two events, because it could either belong to any one of them or to both of them. That belong to, and if they belong to both of them, we just write them once. That belong to at least one. They belong to at least one of the two events. Now the union of any two events, E and F, the union of any two events, E and F, is represented by, so like we saw how do we represent intersection, we'll see how do we represent union, is represented by E union S, represented by U sign. For intersection, we use the inverted sign. We can also write it without the intersection sign, and for union, we use the U sign. So now any outcome in E union F will be in E or in F or both, right? So any outcome in the union of E union F will be present inside E or F or both, but definitely in at least one of them. But definitely in at least one of them. Right, so union is a set of all outcomes that belong to at least one of them. So if you return back to example 3, now from example 3, again, let's just quickly write down what E and F that we just saw. Example 3 was the two dice being rolled. So E here we saw was this. I'm just writing down the outcomes in it. So from example 3, we know E includes outcomes 4, 6, 6, 4, and 5, 5, right? And F was the event that both same number pairs on both dice. So it includes 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6, right? This is what it includes. So from example 3, we know E union F. Now, when we're looking at the intersection, we only look at the common outcome between them. But when we're looking at the union, it's a set of all outcomes. Set of all outcomes in the first event and all outcomes in the second event. So we'll write down all the outcomes, right? So if we start with, we'll write 1, 1. So if we write the outcomes of, it doesn't really matter, let's write the outcomes of E first, 4, 6, then 6, 4, and then 5, 5. So we have all outcomes in the first event, and now we write all outcomes in the second event. 1, 1, 2, 2, 3, 3, 4, 4. Here, we will only write 5, 5, 1. So we've already written 5, 5 here, so we don't need to write it again, right? So any common outcomes are only written once. So note that 5, 5, so note is not listed twice. Note that 5, 5, which is the common outcome between them, the common outcome 5, 5 is not listed twice, right? So the union of two events is just a set of all outcomes in the first event and set of all outcomes in the second event, and any common outcomes are only listed once. Now, let's look at complement of an event. Complement of an event. So now this is all outcomes. The complement of an event is always defined with respect to the sample space. This is all outcomes of sample space except of the event itself. So this is all outcomes of sample space except those that belong to the event itself. So for F complement, so if I want to write the complement of F, for F complement, we will write, so we can either write it as F prime, or this is read as, no, this is read as, so you will read this as F prime. So we can either write F complement as F prime, or we can put a small c on top of it for complement, or we can write it as F bar. So all of these are ways that we can write to represent the complement of F, right? You can either represent it as F prime, put a small c on it, or you can write it as F bar. So basically F complement would be, like we said, all outcomes of the sample space except for the event itself. So everything except for F itself. Basically not F, right? Basically not F. So if you go back to example 3, now remember in example 3, F was the event that same number appears on both types. Same number appears on both dice, and this was all the outcomes 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So from example 3, we know we can write F complement as F prime or a small c on top of it or an F bar. So the complement of F will be everything except for F itself, basically not F. So if F is same number appears on both dice, so it's going to be all the outcomes except for this event that the same numbers appears on both dice. So F complement would be not F, so it would be different number appears on both dice. Right? If F is same number appears on both dice, so F complement should have all the outcomes except for the event itself. It's going to be not F, so it's going to be different number appears on both dice. Different number appears on both dice. So this is going to have outcomes like the first has 1, the second has 2, and the first die is 1, then it has 3, then the first is 1 and 4, and so on, and then you continue with this, and last outcome would be 5, 6. Or it could be 6, 5 as well. You'd have 6, 5 here as well. So the last would be 6, 5. Um, So this would include 30 outcomes. So this would include total 30 outcomes. Includes, we know this, and now we don't have to list all of them. We know it's 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, then 2, 1, then 2, 3, 2, 4, and so on. So in total, it will include 30 outcomes. As from counting principle, we know. So from counting principle, we know it will include 30 outcomes. Because we know the first die can have any 6, but then the second die can only have any 5 because it can't have the first one you selected. So the first dice could have any of the 6 possible numbers 1 to 6, but then the second will only have 5 because whichever you chosen for the first one, you can't repeat that because you want different number of pairs in both types. So the first one had a 1, the second one you would have 5 options, not 6 options, because you can't have 1, right? So total we have 30 outcomes here from the basic counting principle we know. So this is what we mean by intersection, union, and complement of events.